In this video, we are going to discuss about addition and subtraction algorithm. Mainly, we performs addition and subtraction on two types of data. The first one is sign magnitude data and the second one is 2's complement data. First, let's see how we can perform addition and subtraction operations on sign magnitude data. First, let's see what is sign magnitude data. In a sign magnitude representation, the first bit represents the sign bit. The remaining bit specifies the magnitude. Okay. Let the number is like this: 1 1 0 0. Here the first bit is sign bit. If the sign bit is 1, then it is a negative number. Whereas if the sign bit is 0, then it is a positive number. First, let's see the procedure for performing addition operation on sign magnitude data. Here these are the various possible combinations that we have. Here the first 4 are nothing but addition operations. The next 4 are nothing but subtraction operation. So we know the possible combinations. So plus plus, the first number is sign is plus, the second number sign is plus. If you take the second one, the first number sign is plus, the second number sign is minus. Next third combination, first number sign minus, second number sign plus. Next fourth one, first number sign minus, second number sign minus. So likewise we have 4 cases for subtraction operation. So these 4 are nothing but subtraction. So plus plus, plus minus, minus plus, minus minus. Let's see how we can perform addition operation. Here simply there are 2 steps are there. The first one is if the signs of 2 numbers are same. If the signs of 2 numbers are same, then we have to add the magnitude. The resultant sign will becomes the sign of A. Let's take the addition operation. If you take the first combination, the sign of A is plus, the sign of B is plus. So that means both the signs are same. So if the signs of both the numbers are same, then you add the magnitudes. The first number magnitude is A, whereas the second number magnitude is B. So you add A plus B. And the resultant sign will becomes the sign of A. So what is the sign of A? Plus. So likewise, if you take the second one, plus is the sign for A, minus is the sign for B. So that means the signs are different. If you take the third one, so minus plus, so the signs are different. If you take the fourth case, so this is also addition. The first 4 cases are for addition operation. The sign of A is minus, the sign of B is minus. So that means both the signs are same. So what we have to do? If the signs of both the numbers are same, then we have to add the magnitudes. The first number magnitude is A, whereas the second number magnitude is B. Okay, add the magnitudes. And the resultant sign will become the sign of A. So what is the sign of A? Minus. So minus will become the resultant sign. So this is very simple operation. So plus 2 plus 3. So that is nothing but plus 5. So plus of A plus B. So what is this one? So minus A plus into minus means minus. So minus A minus B. So that is nothing but minus of A plus B. And the second step is if the signs of 2 numbers are different, then we have to subtract the magnitudes. So if you take the second case and third case, here the signs of both the numbers are different, then we have to subtract the magnitudes. Here we have 3 cases are there. When A is greater than B, then we have to subtract the smaller number B from the larger number A, and the resultant sign will become the sign of A. Okay. So if you take this one, here the sign of A is plus, the sign of B is minus. So that means both the signs are different. So if the signs are different, then we have to check whether A is greater than B or not. If A is greater than B, then subtract the smaller number B from the larger number A. Now the resultant sign will become the sign of A. So what is the sign of A? Plus. So plus will become the sign. Next, when A is less than B, then we have to subtract the smaller number A from the larger number B. So the operation is B minus A. When A is less than B, then what will happen? A will become the smaller number. So we need to subtract the smaller number A from the larger number B. So B minus A is the operation. Now the resultant sign will becomes the complement of A sign. So what is the A sign here? Plus. So plus complement means minus. So the resultant sign is nothing but minus. When A is equal to B, then we can subtract B from A or A from B. It is our choice because both the signs are same only. Okay. Let us write A minus B. So subtract B from A. The resultant sign will become A is B. So that means both the numbers are equal. We don't have negative 0. We have only positive 0. So the resultant sign will become plus. Okay. So likewise, let us do this one. Here also the sign of A is minus. The sign of B is plus. So both the signs are different. So we have to subtract the magnitudes. Okay. When A is greater than B, then subtract the smaller number B from the larger number A, and the resultant sign will become the sign of A. What is the sign of A? Minus. So minus will become the resultant sign. When A is less than B, then we have to subtract the smaller number A from the larger number B, and the resultant sign will become the complement sign of A. Here the A sign is minus. If we complement minus, then we will get plus. So plus will becomes the resultant sign. When A is B, when A equals to B, then A minus B is the result. So what is the resultant sign? Plus is the resultant sign. So in this way we can perform addition operation. Now let's see how we can perform subtraction operation. Subtraction operation is entirely different to the addition operation. So here the first step is, if the signs of A and B are different, then add the magnitudes. The resultant sign will become the sign of A. So if we take the second case and third case, here the signs of A and B are different. Here the sign of A is plus, the sign of B is minus. So what we have to do? We have to add the magnitudes. So A plus B is the result. So what is the resultant sign? The sign of A. The sign of A is plus. Okay. Next, likewise, if you take the next one, here A sign is minus, B sign is plus. So that means the signs of A and B are different. So when the signs of A and B are different, then what we have to do? We have to add the magnitudes. A plus B. The resultant sign will become the sign of A. So what is the sign of A? Minus will become the sign of A, because minus is nothing but the sign of A. Next case, when the signs of A and B are same, then subtract the magnitudes. Then subtract the magnitudes. When A is greater than B, then subtract the smaller number B from the larger number A. The resultant sign will become the sign of A. Okay. So this is, here A sign is plus, B sign is plus. So we have to perform A minus B. So what is the resultant sign? The sign of A, plus. Next, when A is less than B, then subtract the smaller number A from the larger number B. What is the resultant sign? The complemented sign of A. So what is the complemented sign of A? So plus complement means minus. When A is equal to B, then subtract B from A, the resultant sign will become plus. Likewise, if you take the last one, minus minus, both the signs are same. So what is the procedure now? Then subtract, when A is greater than B, subtract B from A, the resultant sign will become the sign of A. So minus, whereas if you take when A is less than B, then subtract the smaller number A from the larger number B, the resultant sign will become the complement sign of A. So the sign of A is minus, complemented sign means plus. Here A minus B, the sign is plus. Okay. So directly we can write here. So plus A plus B means what? Plus of A plus B. Next, plus A plus B plus minus, plus A plus minus B is nothing but what? A minus B. So directly also we can write. Okay. So in this way we can perform addition operation and subtraction operation on sign magnitude data. Now let's see how we can implement internally in the computer with the help of a hardware. So here we have two registers. The first number is stored in A register. Here AS is nothing but a flip-flop which can store the sign bit. We know that sign magnitude representation means the first bit is sign bit. It may be either 0 or 1. So 0 means positive number, 1 means negative number. That sign bit will be stored in AS. The second number is available in B register. BS stores the sign of the second number. Okay. Next, here we are using parallel adder. We know the advantage of the parallel adder. By using parallel adder, we can add two binary numbers. Parallel adder is a collection of full adders. Okay. Here we have to supply a mode bit. M means mode bit. We have to supply a mode bit as input to the parallel adder. Here we have a complementer. The value of the mode bit may be either 0 or 1. If the value of mode bit is 0, then 0 will be passed as input to the parallel adder. So that is nothing but input carry. So if m is equal to 0, then input carry will become 0. That 0 will be passed to the parallel adder. If m is equal to 0, then complementer transfers the contents of B register to the parallel adder. So now parallel adder has the contents of the B register as well as what is the input carry 0, as well as this A register content is transferred to the parallel adder. So B plus 0 plus A, that is nothing but A plus B. A plus B means addition operation. So addition operation will be performed, and after that the corresponding sum will be transferred to the A register. Here S specifies sum, so that's why here we have written load sum. Here A register is source register as well as destination register also. Okay, and after that if there is any output carry, that carry will be transferred to E flip-flop. E stands for extended flip-flop. After performing addition operation, if there is any output carry, that carry will be transferred to E flip-flop. So the value of the E will be transferred to AVF. AVF stands for add overflow flip-flop. After performing addition operation, if we get any overflow, that overflow will be transferred to this flip-flop. Okay. So this is about addition operation. Now let's see about subtraction operation. We can perform subtraction operation by making the mode control bit as 1. So when m is equal to 1, then this 1 will be supplied as input carry to the parallel adder. So now the parallel adder has an input called 1. Okay, as well as if m is equal to 1, then complementer transfers the complement of B register to the parallel adder. If m is equal to 1, then complementer transfers the complement of B register to the parallel adder. Now parallel adder has B bar content, and this A register content will be transferred to the parallel adder. So now the inputs to the parallel adder are A, B bar, 1. So A, B bar, 1, 1 plus B bar plus A, that is nothing but subtraction operation, A minus B. So we know how to calculate subtraction operation. We can calculate subtraction operation by adding the 2's complement of the second register to the first register. Okay. So after that the corresponding result, subtraction result, will be transferred to the register A register. If there is any output carry, the carry will be transferred to E flip-flop. If there is any overflow, that overflow will be transferred to AVF. Generally when performing subtraction operation, we should not get any output carry. So there is no need to transfer that output carry to the flip-flop. So this is about hardware implementation. Now let's see the hardware algorithm. So this is the flowchart. By using this flowchart, we can perform addition and subtraction operation on signed magnitude numbers. So this is for add operation, augend in A. So the first number is present in A register, add end in B. The second number is stored in the B register. So we know the logic for addition operation. If the signs of A and B are same means 0 0 or 1 1. 0 means positive, 1 means negative. If the signs of A and B are same, then add the magnitudes. Okay. So for that purpose here we have taken AS. This is nothing but comparator. By using comparator we can compare two sign bits or two numbers. Here we are performing exclusive OR operation on AS and BS. So here let AS value is 0, BS value is 0. So 0 exclusive OR 0 means 0. So that means we can say that both the bits are same, both the signs are same. Let AS value is 1, BS value is 1. So 1 exclusive OR 1 means what? 0. So that means both the signs are same. So while if you want to perform addition operation, then we have to compare the sign bits of both the numbers. If they are same, then you add the magnitudes. The first magnitude is present in A, the second magnitude is present in B. So this 0 specifies AS is equal to BS. So 0 equal to 0, 1 equal to 0. A plus B, perform addition operation on A and B, and the corresponding result is transferred to EA. Here we are transferring the result to a register called A. Here E stands for extended flip-flop. If there is any output carry, that carry will be transferred to E. And after that, that output carry will be transferred to a flip-flop called AVF. AVF stands for add overflow flip-flop. Okay. If you take this one, while performing addition operation, if the signs of A and B are different, if the signs of A and B are different, so when the signs of A and B are different, the signs may be either 0, 1 or 1, 0. So that means if we perform exclusive OR operation, we will get the result as 1. We will get the result as 1. This 1 specifies AS is not equal to BS. So that means 0, 1 or 1, 0. Then what we have to do? If the signs are different, then we have to subtract those two numbers. So here we are performing subtraction operation using this. A plus B bar plus 1. So we have to add the 2's complement of the second register to the first register, and the result is transferred to EA, where E stands for output carry. After performing subtraction operation, we should not get any overflow. So that's why the value of AVF is clear to 0. Now let us discuss this part. This is for subtraction operation. The first number minuend is present in A. The second number subtrahend is present in B. Here also we are using a comparator in order to compare the sign bits of AS and BS. We know the procedure for subtraction operation. If the signs of A and B are different, that means if the signs are either 0, 1 or 1, 0, then if we perform the exclusive OR operation, we will get the result as 1. So if this result is 1, then we have to add the magnitudes. So if it is 1, that means if AS is not equal to BS, then you add the magnitudes. So the result is stored in EA and output carry is transferred to AVF. Next, if the signs are same, so that means if the signs are either 0, 0 or 1, 1, then what we have to do? We have to subtract those two numbers. If AS equal to BS, that means AS value and BS value may be 0, 0 or 1, 1. Then we have to subtract the second number from the first number. So A plus B bar plus 1. So the result is transferred to EA. So this is nothing but subtraction operation. After that we should not get, if we perform subtraction operation, we should not get any overflow. So AVF will be clear to 0. Next we have to check the value of E. Why? Because here there is a possibility that we may get negative number. Negative numbers are always represented in 2's complement notation. So that's why we have to check E value, output carry value. If E value is 1, so when E value will be 1, we can say that E value is 1 if the first number is greater than B or if the first number is equals to B. So when A is greater than or equal to B, so any one of these condition is true. So when A is greater than B or when A is equal to B, then we can say that E value is 1. Okay. Then we have to check the value of A. Here what is A? A is nothing but resultant register. After performing the result, the subtraction, we are transferring the result to A. So check the value of A. If A value is 0, then we don't have any negative 0. We have only positive 0. So we can make a number, a 0 as positive by making that sign bit as 0. So AS arrow 0. That means the sign bit will become 0. So it is a positive 0. Whereas if A is not equal to 0, then there is no need to make any change on A. Why? Because here this is nothing but E value is 1. It is a positive number. The first number is greater than B. So here the result is a positive number. So there is no problem. This A will becomes the entire result and result is present in A and AS. Okay. Whereas when E will be 0, if the first number is less than the second number, then we can say that E value is 0. If the first number is less than the second number, and here we are performing the subtraction operation, so we will get a negative number as the result. Negative numbers are always represented in 2's complement notation. Here in order to perform the 2's complement, first we are performing the 1's complement with the help of the complementer. Next we are adding 1 to the result with the help of the incrementer. So the first one is A arrow A bar. So we are complementing A. Next, with the help of the incrementer, we are incrementing it by 1. So A arrow A plus 1. So this is nothing but 2's complement. Okay. So first 1's complement is over. Next one is added. Next we have to reverse the sign bit. So AS arrow AS bar. AS arrow AS bar. So we are reversing the sign bit. So this is nothing but end of the result. So the result is available in A and AS. So this is the very crucial part here. So after performing the subtraction operation, we need to check the value of E. If E is equal to 1, then we can say that A is greater than B or A is greater than or equal to B. Then we have to check the value of A. If A value is 0, then make A as 0, so it will becomes the positive 0. Whereas if A is not equal to 0, then there is no need to make any change here. Whereas if A is 0, then we can say that the first number is less than the second number. If the first number is less than the second number, then we will get negative number as the result. Negative numbers are always represented in 2's complement notation. So first, with the help of the complementer, we are performing the complement operation. Next, with the help of the adder, we are incrementing that value by 1. So now we have a correct result. Then after that, reverse the sign bit. So in this way, we can perform addition and subtraction operation on the sign magnitude data. Now let's see how we can perform addition and subtraction on 2's complement data. Addition subtraction means here we have two algorithms are there. First, how to calculate with the help of sign magnitude data. So till now we have seen about sign magnitude data. Now let's see how to perform addition and subtraction on the 2's complement data, sign 2's complement data. This is very simple. First, let's see the hardware implementation. Here we have complementer and parallel adder. We know the advantage of the complementer. Here internally we supplies mode bit as the input. If m is equal to 0, then complementer transfers BR register to the parallel adder. Whereas if m is equal to 1, then complementer transfers the complement of BR register as well as 1 to the parallel adder. Already we have seen. So here we have complementer and parallel adder. So this parallel adder accepts two inputs. The first input, the first number is present in AC register. The second number is present in BR register. So parallel adder performs the corresponding operations, and after that it transfers the result to the AC register. If there is any overflow, that overflow is transferred to the V flip-flop. Now let's see about hardware algorithm. This is nothing but add operation. The first number AUG is present in AC register. The second number add is present in BR register. We know how to calculate addition operation. AC arrow AC plus BR. So here add operation is performed on AC and BR, and the result is transferred to AC. If there is any overflow, that overflow is transferred to V flip-flop. End of the process. So likewise, this is nothing but subtract operation. Minuend, the first number is present in AC, subtrahend is present in BR. Next, how to calculate subtraction operation? By adding 2's complement of the second number to the first number. So AC arrow AC plus BR plus 1, BR bar plus 1. If there is any overflow, that overflow is transferred to V. So this is nothing but end of the process. So in this way, we can perform addition and subtraction operation on sign magnitude data as well as 2's complement data.